Welcome back. In this module, we'll discuss data transformation, date and time data, and factors. In our last module, we primarily focused on describing and tidying our data with just a little bit of the dplyr package. This week, we'll focus more on complex data transformations. In the first video, we'll cover dates and times. In the second video, we'll cover factors. And then in the third video, we'll wrap it up with an example that I wrote specifically to help you with Challenge 3. As we've learned from reading in data like the railroads example in Challenge 2, the datasets that we encounter are messy, and we have to do some work to be able to analyze them. Transforming our data makes it easier to work with. So we can recode columns so that their values make sense. We can create variables that calculate things like percentages based on the existing columns. And when we convert our data into specific types, like date, time, or factors, we unlock tidyverse functions that are created specifically to work with those data types. To work with date and time data, we use the lubridate package. And here I'll overview the functions that we'll use in our script. There's a few different types of date-time data that lubridate creates. We have date, time, and then the combination of the two, so date-time. Time is time within a specific day. So it's just one day and the hours, minutes, and seconds within it. And then date time uniquely identifies an instant in time, meaning that it has everything from the second all the way up to the year. In general, you just want to use the simplest one for your data. If you have a year column, great, use the year column. If you need to have details down to the second, that's when you're going to use time or date time data. There's a few different ways to create date time data. You can create it through reading in a file, from a string, from individual components, so individual columns like date, month, day, and year, or from an existing date time object, so you can isolate particular portions of that. The first example is reading in a file, and this is just an extra argument from functions like readCSV that you've already worked with. So here, you want to specify call type equals calls, date equals, and then here's the way that you can format it. So for example, percentage capital Y means a 4-digit year, or percentage D lowercase means just 1 or 2 digits for a day. And here we're reading in data in month, day, and year format. So if your CSV or Excel or whatever file has a column that has a date string, this is what you want to read it in, so that way it's already date time structured. Let's say you have a string. You can create the date time data by using functions that match the order that the string is in. So if your string specifies year, month, day, you use YMD. And you can use any combo, and we have functions even as specific as YMD HMS. So year, month, day, hour, minute, second, and you can play with the different combinations. If you want to specify the time zone, you want to use the TZ equals argument in any of these. A good example is UTC. It doesn't use daylight savings, so it's a good bet. But again, in general, if you don't need time zone data, don't use it. If you don't need seconds data, don't use it. Let's say you have individual columns. So you have a year column and a month column. You can create a datetime object by using makeDate or makeDateTime functions with those individual columns as arguments. If you have an existing datetime object, let's say you have year, month, and day, but you only want month, you can pull out something more specific. And again, this is how you can do that. So year, month, and this one is really helpful for when you're visualizing data because it returns abbreviations. You can have day of the month, day of the week, and so on. We won't use most of these in this class, but it's just good for you to know that they exist. I'm going to cover modular arithmetic. Now, modular arithmetic is actually not used on datetime data, but it's helpful for if you have year data, and let's say you want to calculate a rate across decades. This is division that leaves a whole number. And so if you have, for example, 1954, 55, and 56, which we'll see soon, you can create just a single decade for 1950 using this method. I'll also show you an alternative method, which is kind of an older base R method called cut, which cuts a numeric vector into discrete buckets. So again, we can use that for decades or months or something like that. Let's turn to our example script. Here we're using the tidyverse package, as always, and lubridate and forcats are already included. We're also going to use the here package just for file management. So in our first section, I'm going to showcase some of the functions from lubridate for you. Some basic ones. If we use today, the date, the current date pops up in the console. If you want even more detail, you can use now to get down to the minutes and seconds. And this is helpful because you can calculate something like age using today and a date column. So for example, maybe you want to know how old I am for some reason. What you can do is use the today function and subtract something like either an individual column or in this case a particular string value from today. So here, when we do that, we see that the time difference between today and the day I was born is 9,826 days at the time of this recording. And thousands of days doesn't really make sense to me. I can't do that math in my head, so it doesn't really translate to years. What you can do is use the asDuration function, which will tell you both seconds and years. So that makes a lot more sense. You can also create date-time data just by reading in a file. So we're going to create a mock CSV file. It just has one entry, date, with the date of July 11th, 2024. And here what we can do is specify, again, call type equals calls, date equals call date. And then what we do is specify the order that we're reading this data in. So this string is 7/11/24. I initially read it as month, date, and year. When we do that, we get a date object, 2024 7/11. So you'll see through all of these that it always uses the same format. There's always 4 digits for the year up front, and then 2 digits each for month and day. So in this case, we're saying, okay, it's going to be date, month, year that we're reading in. This produces the day and then the month. This one's different. If we read in and say that we're reading in the year first, instead this produces 2007/11/24. So it interprets the first component as 2007, the second as the month, and then the third as the day. Now let's say you have a string value. What you can do is just use the ymd function, again based on whatever order the string is. So 2002, and then 5 for the month, and then 23 for the day. Here we go, 2002, 5/23. And what's great about these functions is that they can read in various date formats. So we have 2002 dash and so on. We have October 25th, 2008 written out, and it automatically converts it to 2008 10/25. And then if you want to use dashes or slashes or anything, here again, we have 1994 12/05. So this is super helpful when you're working with string data. And again, you can set the time zone if that's of interest for you, all the way down to seconds. Here's an example of data that has individual columns for month, day, and year. And this is data that you'll use in Challenge 3. Let's say that I want to combine all of this into a single date. So rather than having to filter year and filter month and filter day, what I can do is combine them. And to do that, I'm using the makeDate function. And then I'm relocating date to be at the very beginning so we can double check. Great, it's of the date object. And now I can really easily filter this data. So let's say I only want to account for data after January 1st of 2000. I filter, and now all of my data starts there. We can also pull out individual date time components. So in the federal funds data, let's say that we didn't have those individual columns and we just have this date. What we can do is use the month function to just pull out the month from the date time data. And don't worry about the rest of this. We're going to cover visualization in a few weeks, but I just want to show you how this is useful. So here we've pulled out just the month from this column right here. And because we've used label equals true, it automatically supplies the labels for each month. One of the more common issues or tasks that you'll have in this class is to break down a data set by decade. So for example, in our federal funds data, let's say that I'm interested in the inflation rate over decades. We can actually use that year column as is, and we can use modular arithmetic. So here I'm going to break it down, and then I'll show you it in practice next. The first thing I do here is I'm going to mutate and create a new column. So I'm dividing year just by 10. The issue is when we pull out just that column, now it just has 195 instead of 1950. So instead we have to multiply that by 10. So we're going to try again. Open up Fed funds rate modular. Let's see, where am I at? There we go. And now we can see that by multiplying by 10, we've converted 1954, 55, 57, and so on, all into 1950. So that's the breakdown of how to use the modular arithmetic. The way we use it in practice, what we can do is create a decade mod column. So decade mod is equivalent to year divided by 10 and multiplied by 10, just to get those individual decades. We can group by the variable that we just created. And then we can summarize the mean for the inflation rate across each decade. And of course, we're going to use NA.RM equals true in case there's any NA values in the inflation rate column. And note here as well that because inflation rate has a space in it, I have to put it in the back quotes for R to recognize it as a column. And then I'm just going to arrange in descending order the new variable that I've created. So here we've turned the federal funds rate data here using the year column into decades with average inflation values. So inflation was highest in 1970 and lowest all the way in 2010. Here I also provide you with code to use cut. Again, it's a little bit more complicated, but at least you know how to do it. What we do here, similarly, we create a new column. We identify what column we want to cut. We identify the breaks we want to take. So we want from 1949 to 2020 by 10. So when we specify by 1949, it actually starts at 1950 and goes up to 2020. And then our labels. Important for you to know that you need one less label than you need breaks. So here, our labels are going to be a sequence from 1950 to 2010 by 10. It'll get us to 2020. We can decide if we want our intervals to be right or left closed, if we want to include the lowest, and then what format we want. Again, percentage capital Y is a 4-digit year. So we've done the cuts here, a lot more complicated than just using modular arithmetic. We can group by the decade cut value that we create, the variable that we created, summarize, and then arrange again. And here we get the same thing. Here, these are just some basics for date time. We're not going to be using a ton of them in this class, but it's really helpful for you to know in case you encounter date time data in the future. And we're also going to revisit this when we cover visualization. So in our next video, we'll cover factors.